countdown.
Yeah.
I can do a quick intro and then just let you rip. Awesome. All right, we're live. And we're live here with Joe Reese. Finally, I get to see one of your talks because, again, you've been doing them, as we were talking backstage, all over the world at this point. And so I've just cheated and got you here. So thanks so much, Joe.
You've summoned me. So it's good to see everybody, though. Hopefully everybody's having a nice day. So awesome. Well, we can dive right into it, I guess. We're going to talk about WTF as data modeling. You know, Ben's a clean-cut guy. I'm not going to swear, but I'll use acronyms for my swearing. So cool. I'll just we'll share, then we can go on. Yeah, share my screen. And Ben will be fielding the questions when I'm presenting. I actually can't see anything except for the slides. So, you know.
I'm here to make Joe's life easy.
Yes, thank you. Cool. Everyone can see that? Everyone can see that. Is that in full screen mode?
Yes, sir.
Cool. So we're going to talk about what the flip is data modeling. What is it and what isn't it? So about me, I wrote a book on data engineering. I also advise, invest in companies. I found companies too. I'm also a recovering data scientist, work as a data engineer still, data architecture, which is kind of amazing given my schedule. Given that I also speak around the globe, as Ben was saying, on topics of data engineering and data modeling, right? And in my spare time, I climb rocks, I still DJ, surprisingly enough, and I read a ton of books. So enough about me. You're here to hear about data modeling, not me. Okay, so motivations for this talk. I after writing Fundamentals of Data Engineering, I really felt like I gave the topic of data modeling, I think, a fair shake. It was enough that you needed to know to get started with data modeling as a data engineer, but I felt like the topic still needed to be explored a lot more. And along the way, in my consultancy, I run a company called Ternary Data. We're a data engineering consultancy. You know, I talk to a lot of data teams around the world, and I keep saying the same problems, really. Data teams ignore data modeling, and this creates huge and expensive problems for these teams. And so I feel like, you know, we're at a critical juncture as an industry. If we continue to ignore data modeling, I think the consequences will be severe. And I'll get into why I think we're ignoring data modeling and also why the consequences will be severe. So why this talk now? Why talk about data modeling? Data modeling seems like it's a lost art. We have lots of fancy tools. I don't think there's any shortage of tools. If you look at Matt Turk's Mad Data Landscape, seems like you need like a James Webb telescope to see all the companies and products on that. But along the way, I really feel like we've lost our way as an industry in terms of just understanding practices. You know, we got, again, no shortage of great technologies. I feel like we have no idea how to use them, right? If you look at stuff like Snowflake, for example, the common criticism, it's expensive. And when I look at the data models people use in Snowflake, it's like, yeah, I can tell you why it's expensive because you're not following what I consider to be best practices with either how you're modeling your data or how you're leveraging these tools. And so, you know, we get what we get, right? I often find that data sets are overwhelmingly a mess, which we'll talk about in a bit. I used to come across really clean data sets, really well thought out data models. And nowadays, I feel like that's a bit rarer, quite a bit. AI is also very popular these days, right? I don't think there's anybody who hasn't explored the idea of using AI at their company, and it's getting a fresh look. And this also means there's a lot of money and attention being put onto data once again, in ways that I've rarely ever seen before, right? But I guess my big question is, if as an industry, if we're not going to take data seriously now, if we're not going to do stuff like data management, data governance, modeling, then you know, when are we going to do it, right? So if not now, then when? So what we'll discuss here, what the fetch is data, what the flip is data modeling, why model data, and we'll go over some key techniques you can use. Let's dive into it. So what's data? Well, what do you think, right? What do you think data is? You can answer this yourself. You know, but it's kind of funny. We as professionals, we work with data all the time, and when I ask people what data is, I get a lot of confused looks. So I think it's start from first principles. If we're going to talk about data modeling, let's actually talk about what data is. There's an acronym here, DQ, whatever you want to call it. Basically, data, information, knowledge, and wisdom. Right? Data is sort of the foundation. It's the building blocks on which we build things like information, knowledge, and wisdom. Data is the raw unprocessed facts and figures that are often without any context. Right? So it converts into information as data has been giving meaning and context. It converts into knowledge, which is an understanding of how information can be used to achieve a goal. And then finally, you have wisdom, right? Applying knowledge makes sound judgments and decisions. Sound judgments and decisions are things that I'm sure people do every day in their work, right? But often I think we lose the perspective in terms of how data facilitates sound judgments and decisions. So here's some examples of what data are. You probably deal with this all the time. You're data people. Numbers, dates, names, addresses, text, images, videos, unstructured, structured data. All these are different elements. There's a lot more. Just want to give you a handful of examples here, but we encounter this every day, right? These are the building blocks upon which we build our craft. And we might get these from different sources, like databases, maybe from some sensors, surveys, maybe social media, clickstream, whatever I typoed there. And the real world, right? Just observing the real world. There's a lot of data in the real world. And so we get data from all these different places here. And this becomes a data model, right? So let's talk about what the fetch is a data model. I'm going to tell you what it's not first, okay? So I think there's a lot of misconceptions out there. When you mention data model, the first thing that comes to mind is somebody says, oh, Kimball star schema, that's a data model. Or maybe one big table. Or maybe your DBT data model, right? I remember talking to one of my friends, and she was telling me she was doing data modeling, and I asked her, tell me what that means. And she said, well, I'm making a DBT models, right? So it's definitely a way of modeling data, but that's not a data model, right? Let's just be very clear. When I mention a model to my machine learning friends, they think it's an sklearn or a PyTorch model or something like that, right? So the word model is overused, but maybe just a bunch of tables. That could be, that's what some people think data modeling is. And I guess whatever else you think it is, right? That's what data modeling is, right? But I think often, especially when we're talking to data engineers, analytics professionals, the thing that comes to mind is like, oh, Kimball, that's obviously a data model. Again, these are techniques of data modeling, right? These are approaches, but these are not data models. I'll explain this right now. So, maybe take a second for you to think about what a data model is and is not. I don't know if anyone wants to type into the chat what they think a data model is, Ben, but if they want to, I can take a couple of answers here and before I move on with my my monologue and rant. Otherwise,
I'm trying to see if anyone has any thoughts. The only thought, or one of the thoughts people have currently asked is like, the only question I have is it data or data?
Data?
Yeah.
Depends where you are. If I'm in Europe, it's data. If it's in US, it's data. So that's answering the important questions here.
Someone
Data
says representation of a business domain. B. Ackerman.
Cool. Yeah, it might be one way of looking at it. Yep. I think the representation, we'll get into this, right? So this is one of the first, I think, examples of what I found to be a good description of data modeling. This is actually from 1978. That was a year after I was born, surprisingly enough. I'm pretty old. William Kent wrote a fantastic book called Data and Reality. This book attempted to describe how we represent reality in computer systems, which if you remember back then, which you probably don't because you weren't around, but computers were new, right? And we're trying to represent, to figure out how do we manage these newfangled machines, right? How do we represent reality? So I'll let you read these. But we are not modeling reality, but the way information about reality is processed by people, right? That's one thing he says. And he says, data models are techniques for representing information and are at the same time sufficiently structured and simplistic as to fit well into computer technology. So notice, William Kent's not prescribing a certain methodology. He's describing ways to represent reality in a computer. Simple as that. Fast forward to another quote by Steve Hoberman, who I consider one of the godfathers of data modeling, especially analytical data modeling. But he says, data model is a wayfinding tool for both business and IT professionals, which uses a set of symbols and text to precisely explain a subset of real information to improve communication within an organization and thereby lead to a more flexible and stable application environment. So again, notice what he's not saying, right? He's not saying it's COD, it's Kimball, it's this or that, right? Inman, whatever. It's like it's a wayfinding tool in this case. It's a way of describing, taking the raw ingredients of data and using it to more precisely explain your business in order to help it run better. I mean, here's my definition, right? I think it's a bit more succinct, but I also wanted to update it more for the machine age, right? I consider data to be used for humans when we're talking about analytics, but it's mostly used for machines when we're talking about applications of machine learning. So I describe a data model as a data model organizes and standardizes data to facilitate believable and useful information and knowledge for humans and machines. So this is the working definition for my new book on data modeling. Believable is an interesting word. So Bill Inman is a good friend of mine, and once he's a person who created the data warehouse, and I'd argue kickstarted the whole modern data industry. But I asked him one time, what's your true north? You've been at this game since the 1960s, and kind of helped start this. And what's the true north? And he said, at the end of the day, it's about providing believable and useful and valuable information and knowledge. That's it. So good enough for Bill, good enough for me. Here's the data modeling flow, right? I think, the two on the left is interesting. We tend to just jump straight into physical modeling, but there's things like conceptual data models, which is where you understand reality, understand the workflow of your organization, understand how information flows, understand the vocabulary, the definitions, and so forth, right? Then you're going to try and, append these into an intermediate step called logical data modeling, which is where you're going to, start combining this information into something that's a bit more structured, right? So we'll get into more of what this means in a bit. But this is sort of the intermediate step between conceptual and then finally, physical is really optimizing your data model for the physical implementation of that data model in your database or data system, right? It doesn't need to be a database, could be a data frame, could be anywhere you're storing the data, but you're optimizing for how the data is going to be stored and queried when you physically model. But all too often, I think we jump straight into physical modeling. We ignore conceptual and logical, much to our detriment. I'll get more into this in a bit. So how does data modeling relate to data? Well, data modeling creates a conceptual representation of data. It defines the entities in the data and the relationships between the entities and the attributes of each entity, right? So you can think of an entity as maybe a table. Relationships might be, relationships between different tables. Finally, the attributes might be the columns in a table, right? But an entity could be anything. You could express this in JSON, for example, as the entity is your top level key, and you have a bunch of values and maybe a bunch of dependent keys and so forth, and key value pairs, and that's kind of how you want to look at it, right? Or it might be an image, right? And in this case, you might be looking at the relationships between objects in an image, using machine learning, and you're trying to describe what's in an image. So again, data modeling is about representing reality on a conceptual level first, and then diving into how you're going to physically manifest it, right? And at the end of the day, data modeling makes data consistent and useful for information, knowledge, and wisdom. And I would caveat this by saying that it's information, knowledge, and wisdom for both humans and machines, because I'm kind of hedging that machines will get really smart at some point and maybe have some semblance of having wisdom. We don't know yet, but okay, so why model data, right? Well, let's first look at the current state of data modeling. I can kind of give you an incentive of why we want to model data. So this is Hieronymus Bosch is one of my favorite artists. This is a painting he did called The Garden of Earthly Delights, where he talks about humankind's descent into hell, basically. So on the far left here is Genesis, where you have Adam and Eve, and the Garden of Earthly Delights. And as humankind propagates, we flourish. But then, we start picking up some bad habits, right? We start committing cardinal sins, so to speak. And that's depicted in the far right here, where it's the apocalypse. And I feel like the far right is where we are. And this far right part of the image is kind of where we are with data modeling. We started out great, maybe back in the 60s, 70s. I think for a lot of reasons, we've descended into what we see on the right here, which is another hellscape of data. So what the Frank happened here? I have a few ideas. I don't think it's a comprehensive list, but a few things. I think that there's a notion of cargo cult agile. We try and stuff agile into every practice, and I'm going to make a pretty good argument that data doesn't necessarily need to be done in an agile way, right? What agile means is, if you read the original Agile Manifesto, is it's a way for better delivering software. Well, data is not exactly software, depending on how you want to look at it. Data, I think, in a lot of cases, especially when you're doing conceptual modeling, is a very much a thinking person's game. And you can't shove critical thinking into 2-week time sprints, for example. It just doesn't work. But the reality is, in a lot of organizations, in a pendulum I described between fast and formal, fast won. And that means the cargo cult of agile means there's no time for formal practices because data modeling takes too long. That's a common refrain that I hear. And this will manifest itself in many problems that you see down the road, but it's like saying flossing your teeth takes too long. But Um, but that's sure where we are. I would say the rise of big data meant that we have different ways of querying and storing data, and that gave rise to a lot of different ways of I would say physically storing data, right? And so but people often equate physical data modeling with conceptual data modeling, and so all too often this led to tooling being too easy to use, right? So NoSQL databases meant if you use Mongo, for example, wonderful tool, it's a document database, but it means you can stuff anything you want into Mongo. It's literally a trash compactor. It's a great one, great, has a lot of utility, but you can also stuff anything you want into that. And so I think the rise of big data meant different ways of looking at data, different ways of dealing with it, because data grew a ton, and this is the reality of it. This isn't necessary. But at the same time, especially as data became more abstracted and tooling, it made it a lot easier to use. And this means data tools exploded, right? The world moved beyond rows and columns, which is totally fine. That's how it goes. And I think coupled with that, data is new oil, and data science being the sexiest job of the 21st century meant that there's a lot of hype, right? People are jumping into data often without a plan. And one other thing I want to notice is addresses the dev and data divide here. So this means that I'm pretty sure every data person can relate to this. You're usually on the right here. Things flow downhill to you, right? Dev teams will create data. That's usually who you're dependent upon. You're depending upon the exhaust of these applications, and all too often, what happens is you're dealing with data that probably isn't meant for analytics or machine learning, right? So that's the old refrain is data scientists has to spend most of their time cleaning data and getting it and collecting and understanding what it is. I mean, I think if we're going to look at data modeling too, I think a lot of the problem is actually upstream with developing good data models to begin with that are used in applications. If you can get it right there, everything else flows downhill in a nice way. But all too often, what we see is crap flows downhill, and data teams are on the receiving end of it. And all data teams can do at this point is, at best, duct tape the problem. You can't make it better. The data is what it is. We'll get back to this in a second. And the trends aren't looking good for data modeling. If we kind of look at Google Trends, for example, if I look at data modeling, it's not as popular as it used to be, right? If I look at some of the standard techniques too, like relational data modeling or dimensional data modeling, you're also finding that the interest over time, it's kind of dead, right? It used to be popular. I mean, it's actually even data way before that far left cutoff point there. And these are things we would talk about back in the day. And starting to see a resurgence of it, I think, in no small part due to people like Seattle Data Guy and myself and others, starting to hammer home the notion of data modeling. But we'll see where it goes, right? But at this point, it's on life support. Again, all too often, data modeling starts and ends at the physical level. Conceptual and logical modeling are largely ignored. I can make an argument that you implicitly conceptually and logically model data, whether you like it or not. Every time you put data into a system, you're trying to represent some aspect of reality, right? But all too often, I think we go overweight on things, and part of that is because the separation of compute and storage is a big one, right? Like, why care if you can just store things cheaply and then query it, throwing as much compute as you want at the problem? But this misses the fundamental practice of our industry, which is like, again, data is a thinking person's game. It's about understanding the enterprise. It's about understanding how data, can make a great impact, right? And how to leverage it. It's fundamentally different than software engineering. Software engineering is typically about shipping features. Especially when we're talking about analytics, it's about using data to understand the enterprise, and it's fundamentally different. You need to not approach things from a physical level. You need to end there, but you start at conceptual and logical. But we have it completely backwards right now. And again, a lack of a data model is still a model. It's just a very crappy model. And I think we live in a world of very crappy models. What it reminds me of is actually, which I'll show you in a bit. But let me show you some examples here, right? I mean, it's not too common, or it's not uncommon to see data teams with thousands of DBT models. Again, DBT is a great company. I do a lot of work with them. I'm not going to blame the tool, but I'm going to blame the fact that without the proper discipline and without the proper knowledge of data modeling, you're going to get thousands of data models in DBT, and that's how it is. There's also ad hoc, reactive, what I call query-driven modeling. I think I unveiled this when I blurted it at a Ben's show a few months ago. But I mean, ask yourself, how often do you get ad hoc data requests from stakeholders saying, "Hey, I just need to get this report. You need to get this number here pretty soon." I think you can imagine what you have. You have query sprawl. You often get a WTF as a data mean when people look at it, because there's no consistent data model. So all too often when people are pulling data, whether it's a department over here or department over there, data doesn't make any sense, right? So it's a huge, huge problem which data modeling could help solve. I see often we're reinventing the wheel, right? I see things like activity schema and other approaches, which I think is just a simple reinvention of practices that have been around for a long time. I think that we haven't, a lot of people haven't taken the time to digest and understand the basics and the classics of the industry and the shoulders of the giants upon which we sit, right? So there's a lot of reinventing the wheel. One big table is another one. That's, I think, an anti-pattern. It works sometimes. Often it doesn't. But again, that's a reinvention of the wheel. And finally, there's data hoarding and sprawl, right? There's so many data teams now that have infinite number of views, tables, and et cetera. And it's just hard to manage, right? It keeps perpetuating. Reminds me of those hoarders shows you see. So this is this picture of a data engineer with all of his data models. This is very much, I think it's very prescient, right? We don't want to throw anything away. This gentleman here probably wants to keep that, that base quick cookbook along with his phone over there on the right, or the box of green tea on the upper right there, and some old catalog. But this is very much the data systems that most data teams have to deal with now. It's an utter mess. It is an utter mess. It's almost better to burn it all down and start over, in my opinion. But so yeah, this is who we are as an industry right now. This is the face of us. So again, why model data, right? Why model? That's the original question I asked. Your data will better facilitate information, knowledge, and wisdom, right? The time invested up front means far less technical data and organizational debt later, right? Pay me now, or you can pay me 10 times the amount later. You got to look at it like you're against the clock and you took out a payday loan. You can either start paying it now or you pay it later. And most teams want to pay it later for some dumb reason. They don't want to put up the time up front to think about the data, think about how data is supposed to be used. It's about, getting results today, but results, I'm going to argue you're going to do a much better job if you can put in the time up front and do it the right way. You do it the wrong way, you're going to get what you get, which is what we're getting right now. A solid data model improves understanding, communication, and performance. I think this is inarguable, right? And finally, I'm going to make a very strong argument that ignoring data modeling is professional malpractice, right? If your doctor ignores standard procedures like washing your hands or sticking to protocol, they're going to lose their license, right? And data, I feel like if you ignore data modeling, if you ignore a lot of the standard approaches, if you feel like you got a better idea on how you should do stuff, and you don't know what you're doing, then I think you're guilty of professional malpractice. I think you shouldn't be working in this industry, to be frank. You should be doing other stuff, like maybe working at a payday loan place or something. I don't know. Let's go over some key techniques, right? Some key techniques you can use. We can look at patterns. We can look at normalization, denormalization, what I call mixed model arts. Let's dive into this here. Patterns. Very few people know about these patterns, right? But there are cheat codes that you can use at the conceptual and logical level that are going to save you a ton of time. I'll show you some books in a bit. But patterns are really, people have gone through and identified ways of using data to describe realities of different types of businesses. So if you're a retailer, for example, right, there are data model patterns out there that you can use. They'll get you like 50, 75% of the way there already, right? Notions of customer, orders, products, shipping. Like these are like pretty standard things that every retailer does, right? And so, and then obviously the other 25 to 50% of the modeling work is specific to your organization, but leverage patterns. It'll help you get things done the right way the first time. It establishes a foundation. Just like if you're going to build a house, or there's certain blueprints that you can use. You're not going to design a house from scratch. That'd be really weird. But I think all too often data professionals, we want to design things from scratch because we think, well, I don't know what we think, but we just do it anyway, right? But using patterns speeds up your data modeling work the correct way. Here's an example, right? So this is from a book called Data Model Resource Book. And this describes a very generic modeling pattern called the party and role pattern. So you might have a party, which could be a person, it might be an organization, it might be a customer, right? So this generically describes how to think about the relationships between a person, a customer, an organization, and the roles that they may have, right? You can extend this to anything, right? So again, this provides a very high level view of looking at data with respect to your organization. It even has things like, different types of joins. You can have one party with many roles, for example, right? Or one role with the many organizations and so forth. So this is, I think, a very concrete way of looking at your business, which you may not have considered. I would urge you to look at this. There are 2 good books here. Actually 4 good books, because there's 3 books in the data model resource books. There's 3 volumes written by Len Silverstein, which is a monumental effort. I think there's like 2,000 pages in here. And a really good book written by John Giles out of Australia. He wrote this book called The Nimble Elephant, which I consider one of the best data modeling books I've ever read. John Giles is one of these interesting people. I consider him to be this Yoda-like person in data. I've very rarely met somebody as I guess intelligent about data as him, right? And these he wrote a book on using patterns to create data models. So I think one example he gives is he had a month to create a data model for a company and got it done in 8 hours using these models in the data model resource book. So leverage, I'd say rediscover these patterns. They're so relevant. I've read these books, and I think that they're still highly relevant to today. The structure of a business, the workflows haven't changed that much, right? And again, these provide the conceptual and logical blueprints upon which to build your data model. Let's look at normalization. This is a technique that I think is overlooked often, but provides a lot of utility. Normalization, we may talk about first, third, Boyce-Codd normal forms, but basically it removes redundancy and improves data integrity at the end of the day. I think normalization helps you think about the relationships in your data, right? In a way that's based on set theory and predicate logic. So it's based on math, right? Which I think it's pretty cool. But normalizing data, right? So it helps you understand, okay, so if I'm going to make if I'm going to structure my data in a way, how do I do it in such a way that I don't have built-in dependencies, right? So if I need to do say an update or delete on data, I'm not going to cause a side effect, right? So if you can get your data in a third normal form, I think this is a brilliant exercise to do. Even if you don't plan to use it, it just provides a really good blueprint to think about the various entities and the attributes and relationships between all these entities in a way that you just won't be able to do otherwise. Again, it's based on simple set theory and first order predicate logic. The sets are basically, okay, so like how do the elements of one set relate to another, right? Again, this is very simple math, but it helps you understand the relationships of your data before you go any further. I would urge data teams to explore the use of normalization on their own data sets. I think you can find a ton of value. And once you've normalized, before I forget, this is a paper I would suggest reading too by Edgar Codd, aka Ted Codd. This is written in 1970, and this is basically describes the relational data model. This is the first paper written on it. So I'd say I always go back to the source, and I would say read this. It's still a terrific read. It also kind of dives into a lot of the challenges of data systems that they had back in the day, right? I think the databases used to be network and hierarchical databases, and he goes through kind of the limitations of that and why the relational model is superior. I think to this day that the relational model is still the best way I've seen to really truly slice and dice your data. I've never seen anything that matches the simplicity and I guess the sheer elegance of it. So, but this paper is a really good exposition into it, and you should read it. It's a classic. Denormalization. So once you've normalized your data, you can now denormalize it, right? An example is a Kimball star schema, right? Ralph Kimball came up with the star schema and dimensional modeling precisely because the problem with relational models, if you put them into a database, is you might have a lot of joins. Sometimes these are performant, sometimes they're not, right? So, and the notion is, with denormalization, especially with Kimball's way of doing it, is you want to be able to separate the events from the things that describe the events, i.e. facts and dimensions, right? So he provided, I think, a very convenient blueprint for that. Whether or not you want to use that is up to you. But first, I would suggest normalizing your data again, and you can go ahead and denormalize. You can even put it into one big table if you want, right? But I think all too often what happens is data is actually unnormalized. We just throw everything to one big table or just a bunch of tables and don't think about the structural integrity and the how do I eliminate the redundancies and the duplications of my data. That's a missing huge piece of foundation. And then what happens is you get unnormalized data sets. Again, one big table that, these things are just hellscapes, right? They're unreadable. Updating them or if you have to update them, it's going to be really hard. There's often lots of duplication. And just the data is a mess. It's not coherent. It doesn't describe things at the grain that's proper for analytics, right? And so what I noticed when I was in India a few weeks ago or a couple weeks ago is somebody told me they made one big table and that got too untenable. So they had to make another big table on top of that one big table. And now they had just a bunch of one big tables on top of a source one big table. And he asked what he should do about that. And I said, you're probably gonna have to burn it down to the ground. This thing it's incoherent. It's expensive to update. It's expensive to maintain. I'd say start over. Just a bunch of tables. This manifests itself in basically, so I'm drinking some coffee here. Maybe have a bunch of DBT models that are each creating one table. Now you have thousands of tables. I don't know how these relate to each other. Maybe they do, maybe they don't. Oftentimes I see is people daisy change these tables together and do just a bunch of one big table workflows, and it's just a mess. It's just a mess. If the best data models I've seen are just very, very simple. They do one thing and they do one thing really, really well. And I think that's what you should strive for, is just simplicity, not chaos. Right. But denormalization only works if you normalize your data. The other track is just don't normalize anything, and then you get normalized data, which is, I think, the default that we have now. It is what it is. And finally, there's mixed model arts. And this is a quote from Bruce Lee, one of my personal heroes. I think I consider Bruce Lee to be the person who came up with mixed martial arts with his work with Jeet Kune Do back in the day, which is combining all the different styles together. And I say that, learn what works. There's a lot of different techniques out there, far too many for me to describe here. But learn the techniques that have worked over time, in different situations, different data modeling techniques, and learn the trade-offs, learn what works your situation. Maybe one big table is what you need to use, but understand why you'd want to use it. Don't just take it at face value that that's how you have to do it because some blog post said you have to do it. As Bruce Lee says, use only that which works and take it from any place you can find it. Right. So I think hopefully you follow this advice here. But again, think about data modeling across a life cycle from where it's created, an application, maybe it's using analytics, maybe it's using machine learning. There are different techniques you can use. Maybe for streaming, there's different ways of modeling data there too. But just understand the various techniques. That's what my book will aim to provide, is the sort of the end to end from data creation to its archival or death of different ways to model data and how you can use it. Show you the trade-offs, and from there, you can make sound decisions on how you want to chart your course with data. But all too often, again, I think we're blind when I talk about data modeling, especially with data engineers, analytics professionals. First thing that comes to mind is, well, should I use Kimball or one big table? Right? And I think it's a dumb question. You haven't considered the conceptual or physical or logical modeling of how you want to describe the reality of your business first. And so for you to jump straight into a specific modeling approach, a physical modeling approach, I think it's very, again, I think that's professional malpractice, to put it very bluntly. So again, kind of expanding on this, the life cycle is right now, dev teams throw data over the wall to data teams, right? But hopefully, with good modeling techniques, we can start bridging the gap between dev and data. And by data, I'm also including data science teams and so forth. But the times come when we need to understand data modeling up and down the data life cycle. I think the days of lobbing data over the wall and having data teams work with it, and handling it, I think those days are over with the rise of data products. And we need to think in bidirectionally, and consider just the life cycle of data and how we can all play a part in making sure that our data, across the life cycle is of the utmost integrity and usefulness for a specific use case. So that kind of ends my monologue here. Again, we're at a critical point in the industry. Now is the time. If we're going to do data modeling, let's do it. It's a key to making data and AI work. And yeah, let's bring back data modeling. So you can get a hold of me on LinkedIn. If you haven't subscribed to my Substack, there it is. joereese.substack.com. You can take a picture of that QR code and also join me on LinkedIn. I have a weekly rant that comes out on my Substack every week. And so, it's a good place to catch up with me. I'm also going to be launching a part of my new book on there called Practical Data Modeling. So stay tuned for that on Substack. And then another announcement is coming in 2024. Deep Learning AI and me are launching our data engineering specialization on Coursera. So if you want to learn more about that, you can click that QR code or take a picture of it and sign up for early information on it. But I think this is it's going to be huge. So anyway, enough about me. I will stop sharing here and maybe I'll answer some questions or send off hate mail, whatever we're into here. So yeah, thank you.
Yeah, no, thank you, Joe. Cool. Yeah, I mean, I think, if anyone has any questions, you can ask them. But I think there was at least some things I can form questions from. One person pointed out that, maybe they wouldn't necessarily blame either the application team, the dev team, but possibly like management for pushing, for unreasonable deadlines. Is that something you feel like you see?
Wait, say that again.
Essentially, someone
Sorry.
pointed out the fact that, right, like, one of your points is that often the dev team kind of pushes over their data model or lack thereof onto
Yeah.
the data team. And one person pointed out, like, oh, well, maybe we shouldn't blame the dev team as they're often pushed by, management. And I think you also brought up that their goal is very different. So how do you
I'll blame the
reconcile?
I'll blame the dev team. So
All right.
well, okay. So data modeling. One of the things I'm pointing out in my book is data modeling is actually 10 times worse when you're writing software.
Yeah.
Right. So, I mean, I used to be a software engineer. I think I know how this works. So in a lot of cases, software engineers are using object relational mappers, ORMs. So,
Yeah.
And that even if you have a well-defined data model at the beginning, you know how easy it is to add new fields to your model file, for your app. It's insanely easy. And so that's I would say that, and what happens, this manifests itself into creaky application databases, right?
Yeah.
Or better yet, you're using a document database like Mongo, for example, which is an awesome database if you know how to use it. But then you come up with this untenable collection of data. So I would say that it's almost worse in software, and it's incumbent upon dev teams, I think, to also revisit data modeling, because data modeling, again, it's a life cycle thing. It's not just analytics only, even though that's the world that we tend to live in, or data. So yeah, I would say it's all their fault.
Yeah, I think like you encapsulated well with that statement that I'm going to definitely write a post about here in like a minute, where you said, normalization, like in order to denormalize your data, you need to have it normalized first, right? Like,
yes,
like otherwise, like similar to the statement you said, is like it just becomes 10 times harder for the data engineering side to try to translate whatever it is that you're sending them over and be like, okay, now I have to put more effort into it. Rather than if you would have given them something that's like pretty standard, they're like, oh, I know how to
and it's
genuinely
clean,
do
right?
this. Yeah.
Yeah, I was talking with who was it, Ananth Pakaldiri about this. The guy from Data Engineering Weekly, and he was saying, well, the data he got one of his jobs is, was all normalized, right? And I was like,
Yeah.
well, there you go. And he's arguing, well, we need a data model. I was like, yeah, because they just did the hard work for you, actually. So you can do whatever you want with it now.
Yeah.
But if it wasn't, I mean, you'd be scratching your head. Okay, so how do I make sense of this, right? So I mean, yeah, but it's an overlooked step for sure.
Yeah,
for sure.
Yeah.
Yep.
That was something I always felt spoiled at when I worked at Facebook, was like, oh, integrating data, that's easy. That's not a problem. All of our stuff talks to each other. So like IDs, easy. And all these steps that, you take for granted, I think, when you work in maybe big tech or something that's better integrated. Whereas when I've worked at like a hospital, it's like, yeah, we're trying to join the project data to the hours of the project data, but those are collected in two different systems. And so it's kind of chaos in trying to make that connection, even though they should be pretty straightforward. Let's see.
I'm assuming through the comments here. I'm seeing how many people I offended in my talk here.
No, I think most
all
people
good.
here enjoyed it. So, is there just a Q&A section? Oh, there's just a Q&A.
Oh, there's a Q&A section too. Yeah.
Yeah, sweet. Let's see. Where's it start? What's the oldest new? I don't even know. Possibly thorny question. What is your opinion on the necessity of data contracts for sustainable data modeling?
I think they're great. Next question.
There you go. Next question. As someone who is somewhat removed from data modeling, what is the advantage of normalization versus normalization plus denormalization? Apologies if this was covered.
Yeah, I think we kind of covered it, but in a nutshell, basically, normalization it keeps your model clean, right? And so it keeps it free of any transitive or passive dependencies with other data. And why is this important, right? If you remove redundancies, if you remove dependencies within your table, for example, this means you're free of side effects, right? It means everything stands uniquely on its own. So if I needed to delete or update, I'm not having some sort of side effect down the line that's going to like completely mess up the data model. That's why it's important. And from there, you can denormalize, but you need to start normalized.
Yeah.
You can't take away from what you don't have, I guess, is the point.
Yeah. That makes sense. Next, I think this is always a question, like, how can you cultivate the skill to model data that makes it explainable to all stakeholders, even if your manager is not technical? I'll be kind in the word choice there.
Yeah, no, it's a tricky one, right? I think, but it comes back, I think, to a broader need to be really good at just communicating what it is you're trying to say, right? And so I think if you are good at explaining simple things, this should be a good exercise for you, right? And so I think your data model at the end of the day should be very simple to explain,
Yeah.
right? But it entails, but being able to explain something simply entails that you understand what's happening. So it entails that you've looked at your business, you understand how, just the process flows and the information flows and how everything works together. If you can understand that and articulate that, you already have your data model. You just haven't built it yet.
Yeah.
But if you don't have that ability to see sort of the flow of everything, then I don't know. I suppose you're kind of blind.
Yeah.
So, right.
Yeah. Yeah. I think something that I've been thinking back, 'cause like part of the issues that I think we've been running into is like losing the why for a
Yeah.
lot of the stuff we're doing. And I'm like, I feel like with things like LLMs, ChatGPT, we'll lose it more because
Oh
we
yeah.
have to think less. It's like, oh yeah, like I'll just ask ChatGPT to like model my data, which maybe that's fine because maybe we'll actually follow good practices.
Maybe it is.
But
Yeah.
but I was
I
thinking
mean,
about that recently.
well, I was thinking about it too, and I think maybe that's one way to do it. I think it still entails you have a good domain expertise of your business, but if you can couple that with large language model and it does the job that otherwise people are going to you know um, ignore, then I would say go for it. At this point, I'm willing to take any Hail Mary that we can. I mean, if we need to hire elves to come in and help us, I'm sure that would be great too. So, but it's kind of like a code red situation with data modeling right now. I mean, the industry is actually in a code red situation, I'd argue, in general. Again, we don't have any shortage of tools, but I argue that like the biggest crux that we have as an industry is like we don't have the context, we don't have the knowledge or the skills to properly leverage these tools to the fullest capability, and it manifests itself in exactly everything that you've seen in your consulting, and same with me. So
Yeah.
which I mean is great for us. I shouldn't be talking about this. I should be like, everything's great. I don't know. Just gaslight people. Like, I don't know what you're talking about. Like, your data sucks. Like, why?
Yeah.
But
Yeah.
I won't,
You want to be consulting forever, I hear. Is what I hear. It's like you're like, I never want to stop. I want to be 75 and still being called on the same problem. See another question here. What are the unique challenges that make tech debt in data modeling better or worse than tech debt in traditional code bases?
It's an interesting question. I would say it's because things break silently, right? So if you don't have observability, for example, the worst thing you want to do, the worst type of debt you want to do, and this is why I mentioned organizational debt as part of the data debt and tech debt, is I view things as a punch pass. As a data team, you probably get, let's call it a punch card of 10 screw ups that you can make before you're all gone. Before me being the boss is going to say, you've used up 10 punch passes. I'm sorry, but it's probably time to part ways. And that's the reality of it, because things fail silently. Things manifest themselves in interesting ways, right?
Yeah.
It's not a matter of correctness sometimes. It's a matter that data becomes unbelievable. I'll give you an example, right? Like early in my career, I don't know, systems weren't updating, or I gave my boss maybe the wrong data and he made a decision on that. That sucks. I lost a couple punches off my punch pass on that, right? And all too often what happens is, if you don't have observability set up, for example, then it's like, okay, an exec's going to find a report. Some inevitably will be wrong when maybe a database hasn't updated the data and they're making decisions on this. Then, hey, come to find out, it wasn't updated. So stupid Ben over there and the data team there screwed up. Data's 3 days old. And that's a reality that happens still all the time. So that's, I would say, the difference. With tech debt and software, it's like you kind of know, because you have unit tests, right? You probably have a CI/CD process that'll catch builds, and finally, you have tons more monitoring set up on your application. So if there are things that are wrong, you tend to know, right? Hopefully, sometimes you don't, but that happens too. And then whatever, your punch pass goes away.
Yeah, I was gonna say, I think that's always the hard thing. Like, you can make the code work the way you want from a data pipeline standpoint, and it'll still be wrong because, again, data is either loaded at the wrong time, or something goes out of sync, or I'm using this current example because I like it. I had a client where it's like they were used to getting megabytes from a source in terms of how the data was coming in. Something was coming in as bytes, and they're like, "What's going on? Why are we seeing 100x numbers here?" And it's like,
Whoa.
I don't know. That's weird. So it's like those things happen though. It's like something happens at the source system where it's like, okay, we're reporting differently now. We didn't tell
Yeah.
you, by the way. Now
And you're
go
like,
report those numbers to management and try. Hopefully they don't see it
yeah, it's like,
before you have a chance.
whoopsie.
Yeah.
Yeah.
Okay, going back to we're blaming the dev team.
Blame them. They're the root of all evil. I'm kidding. I like the devs.
I know. Any takes on Data Vault 2.0?
Nah, I can't say I'm a data. I can't say I'm proficient enough in Data Vault to have an opinion one way or the other on 2.0 versus 1. So I think it's a good practice. I will say that I see more Data Vault being used in Europe. I think, and let me dive into this for a second. So I think it actually provides an interesting cultural exposition and difference between. How much time do we have? I know I just said we're ending, but I mean,
like the Q&A is like 15 minutes after, so it's like
well, we keep talking. But it's like, so Europe's an interesting one because there it's impossible to get fired, right? And companies like move a lot slower. So what I see is data modeling practices, just like thinking around data, is a lot more rigorous, right? People have time to think about stuff precisely because they're not caught in a constant cycle of sprints. Data Vault, I think, gets a wider adoption there precisely because there's a few reasons. One, it provides better lineage for your data, better traceability from an event standpoint. And so that I think that audit log is something that's definitely a lot more applicable to some place like Europe where it's highly regulated, for example, right? There's just more regulations there. I kind of joke that the Data Vault's sort of the David Hasselhoff of the data world, where it's like was born in America but super popular in Europe. Yeah, it's cool though. I mean, you just don't see it a lot in the States yet, but I hope it changes. It's a great technique.
Yeah. I think that was something you brought up that I thought was very interesting. It fits in the whole like regulatory body kind of approach that I think the EU has, which. Yeah, I'm not gonna like. I don't know what's more necessary. I think it's a good relationship. I think in a weird way.
Somebody in Paris, I remember after a talk I gave in Paris earlier this year, somebody came up and told me like, you got to know, Joe, the US innovates and the EU regulates. And I was like, yeah, makes a lot of sense. So
it's a healthy relationship, sort of. Was asked. Someone asked, what kind of music do you play when you DJ?
I play a lot of house, techno, and like rare disco. So kind of the mix of all those. I'm pretty old school. I've been DJing since the late 90s, early 2000s, like 2000-ish. Yeah. So my music tastes go pretty far back. Yeah.
Nice. Let's see. Okay. Well, I think you kind of answered this, so I'm going to ask you, and this person's asking you a question. So team owns. Let's see. Is there typically a specific role or function or perhaps team that owns data modeling at an organization? Is it data architects, DBAs, data scientists, data engineers? Maybe it depends. And on the flip side, is there someone who should not be data modeling? I like that flip
side. Maybe the janitor. He should be data modeling too, or she. No, so I think it's highly dependent upon your organization where you work, right? And so I think it depends. Like you worked at a big company. I'm pretty sure like in that case, it would make sense to have a dedicated person who focuses on models. But it's really how do you communicate those models to the broader industry or broader teams, right? And so I feel like it's a lot like architecture these days, where I feel like the practices of architecture really need to be distributed to everybody, and you just need to know the basics. I think with data modeling, it's one of these things where I think as long as it's not that hard, that's the whole thing. It's knowing the techniques and knowing how to use them. But I think just because of the way teams are going, I feel like a lot more pressure is put on data engineers, data scientists, developers. And so I almost think of it like data model ops in some way, where it's incumbent upon teams and it becomes more of a cultural thing versus a job. Unless your company is, again, big enough to have it. I know in Europe, it's more popular to have data architects, dedicated modelers, and that works perfectly for those types of companies. But if you're talking about like a modern American company, whatever that looks like, it's like, I don't think it's going to work. But just it gets highly dependent on the company. There's not a one size fits all answer to this.
Yeah. I think the only point I'd ever have to that is I remember seeing an article from Airbnb that I quote all the time, even though now it's 5 years old. But they had like the data scientists and software engineers doing the analytical side of data modeling, and they quickly decide that's not a good idea. And they're like,
it all depends, man. I mean, it could work, it could not. But I mean, but it actually brings up an interesting point because data scientists are using data frames, which are memory dependent. not stored typically, right? They might persist in some way, but that's a totally different ballgame. And so I think that, but having modeling techniques for data frames, I think that's an interesting one that I think is still TBD. So, yeah.
Is there not a modeling framework? Yeah, not really, huh?
I mean, there are fundamental differences between that and databases, right? Like the transpose operation, for example, you really can't do in a table. But and you don't have like row and column names like you do in a data frame, right? So,
I'm trying to see. There's so many questions. Also, if you need to leave, let me know.
I'm having fun doing this. Otherwise, I'd just be hanging out with my dog. So,
here's a question. For startups, when is it a good time to start building their data model for warehousing instead of just creating dashboard metrics directly off their transactional data?
Like today.
So would you say even if you are a 10-person startup,
I would say you should think about it. Actually, this is the time you can get it right. It might be one of the only times you can get it right without a lot of the baggage and a huge rewrite. Like if you can get at one startup I was at, like we when it came time to design our data warehouse, like we really thought through, okay, so what are the relationships? Like what are we trying to do? Like that was a lot of work. But at the end of the day, we understood the business, we understood how we're using data to report the business and everything else. And I think without that, if we were to take the opposite approach, we're just like, screw it, we'll just do ad hoc kind of stuff. It's like, I don't know that we understand what we're doing because everything is so mismatched, right? And so, but that also applies to the model you're using for your application, right? So I think this is a team exercise. Now, of course, not every startup's gonna data teams are usually like the last thing that are hired at startups. Typically, you're gonna hire engineers first, right? So I'd say like it's incumbent upon the engineering team to also get the data model right. But that makes everyone's life easier.
Yeah, I've definitely noticed that it's generally there just does tend to be this point though where like they're like, okay, we've been relying on either some sort of layer on top of transactional data or something. Software engineers don't want to do that anymore. Let's hire someone else to do it.
Yep.
Speaking of software engineers, here's kind of a one we can throw the other way. What is something data engineers can borrow from software engineers as a best practice or ethics?
For ethics?
I don't know. I said best practice, ethics, but I think we could
do your best and don't screw people over. I think that there's a lot to borrow from software engineering. Obviously, data engineering and software engineering is different, but I think that as I always kind of quip, if you want to see where data is going, just look at where software has been for the past 10, 20 years.
Yeah.
Right. I mean, every practice that we're doing as a field has some inspiration from software. It's just more mature, and they've been doing it longer, and there's a lot more cycles. So I would say but we're starting to get it right. I would say we mentioned observability. That's a thing. Ops. That's been around for several years now, and data ops and DevOps. I would say to take it a step further, if you really want to know where things are going and you want to get perspective on how things should work, take the time to study things like lean in supply chain and manufacturing, because that's where DevOps got its ideas from. It's not like DevOps like suddenly appeared on the scene. It's like they actually took inspiration from lean manufacturing. And what happens there? Well, the benefits of looking back at the past, which I do a lot now, is you sort of know where you need to go forward. Lean provided a great framework for reducing waste or eliminating waste and reducing bottlenecks, right? That's essentially in software, you had batch oriented mode. Now you have CI/CD, continuous. And that's because batch is a cardinal sin in lean. And I think as much as that goes, the other thing you're going to see, I think, drawing inspiration is, real time is going to be a first-class citizen. I think we'll look back on the days of batch and data land as being sort of the equivalent of a dial-up modem at some point, which I used to have back in the day. But
I'll have to ask some questions tomorrow. We have a batch versus streaming discussion.
Oh, fun!
And and then also tomorrow seems to be a lot of just streaming talks. We have like that plus 2 other talks from people.
Oh, fun!
Talking about
that'll be a lot of I'll tune into that.
Yeah, nice. Let's see, where did the question go? I think this question is basically asked. I'm going to kind of try to frame this if I can. Essentially, put the functions, or is this model expected to account for the business specifics? Actually, I can't figure out how to ask that question. I feel like there's a good question there, but I can't figure out how to ask it. Yeah, any rules of thumb in terms of like choosing the right data model when you have so many techniques?
I think you just need to understand your situation and what you're trying to accomplish, and couple that with the techniques available. So if you were to look at this from a mixed martial arts perspective, right? Say you're in a fight.
Yeah.
It's a crass example, but it's something that whatever. Yeah, imagine you're in the UFC and you're fighting an opponent, right? You want to make sure you're good at a lot of things because your opponent is good at a lot of things. And the way fights go is they're impossible to predict out of the bat, and you just have to, I think, be able to adapt to different situations as a fly. In much the same way, you need to have an arsenal of data modeling techniques at your disposal and know when to use them. What's the trade-off? What are the pitfalls of this? What are the advantages of this? Is this a temporary thing, right? Am I scrambling? If I'm on a fight, right? I'm trying to get back to my feet, out of position, right? Is this a temporary thing I'm trying to do in order to get me to where I need to go? That might be perfectly fine too, right? But I think ultimately you need to understand the variety of techniques and really be good at applying them when they need to be applied. That's how I look at it.
Yeah. So you're saying is who's the wrestler in this in the data versus the striker? In the data modeling world?
Yeah. And I'm kind of curious what the wrestling is, right? Because I think I think the old saying is if you want to pick one martial art to be really good at an MMA, if you're starting from scratch, it'd be wrestling hands down. You can dictate where the fight goes, but or running away real fast. It's another option. Sometimes that is the option you should take, actually. And when you're modeling, it's like sometimes you need to go and like regroup. Don't just.
Oh, I thought you were gonna say run away. I thought you were gonna say like quit your job.
Well, sometimes that also might be a reality, Ben. Sometimes it's so foobarred that you might that might be an option, or maybe you'll be asked to go run away. So I don't know. I've seen this happen too.
Yeah. Let's see. Have you seen any adoption of data mesh in the industry for normalization?
Not for normalization, I would say, but data mesh is definitely getting adopted. I think that there's a lot of companies out there that are making efforts to adopt the data mesh approach. Zhamak Dehghani is one of my besties, and so I think that the work she's doing is on data containers is going to push it to the next level. But for example, last week when I was in Dubai, Zhamak and I were giving a talk to a bunch of chief data officers from around the world about data mesh, right? And so I think the appetite's there. And it's just going to continue to be there. I think if data mesh takes hold, it'll fundamentally change the entire landscape of the data world, I think, for the better, because now we're talking about data products. And that's really, I think, the next cycle of stuff is where it comes full circle. Data and software and all that stuff is basically combined. And it works.
Yeah.
Mm-hmm.
Yeah. I think one of the things with data mesh is like, it's one of those things that there are plenty of companies who are doing it and probably don't even call it that. Like following the principles too, like when I worked at Facebook, no one called it that, but like the idea of like treating data as a product and having like domain ownership, I'm like, that's how we did it. Because you have 1,000+ data engineers, you're not going to tell them all, have one governance team try to tell them how to operate. Like, you're going to do it this way.
Right.
Like, well, there's 1,000 of us. Good luck.
Corralling
us cats.
And that's just it. I think that's the vision of it. It's a decentralized, sharing of data assets and products, across domains, and that's literally all it is. But at a scale of Facebook, I can only imagine that you have so many domains. That's the only way it would work. To your point, what it was, Mark Zuckerberg going to get up there and like dictate how you're going to model your data and all that? Like, I don't think he has time for that.
Yeah.
Elon Musk.
No, he's I was gonna say he's training to fight Elon Musk. He's got no time for this. Have you seen him? He's ripped right now. He's on.
Elon's not looking too ripped. Yeah, I think Elon's.
No, not Elon, but
Mark Zuckerberg. He's looking good, man. He's looking good. So
I don't know. I need the TRT that he's on or whatever.
It's a blood of teenagers.
Oh yeah, there's that too.
In Silicon Valley. Cool. Yeah. Anyway, fun times. I know you're coming up on time here, man. Cool. Well, it's good chatting with you, man. I'll hopefully see you next week. But So thanks to the audience. Great questions. Great comments, and it's great to see everybody here. So
thank you. Thanks so much.
Awesome.
All right.
All right. Take care. Bye-bye.
Bye.